Evaluating machine translation is tricky. We have automatic metrics like BLE or commit, but human evaluation remains the gold standard. But even with humans, things can get difficult or otherwise expensive. In this video, we'll cover two new annotation protocols, ESA and ESAAI, which are based on these two papers. The simplest thing to do is to show an annotator the source and assistant translation and ask them to give you a score on a scale from 0 to 100%. This is called direct assessment and it's simple and fast. However, it's also sometimes vague, and for a sim translation, two annotators can give you very different results. Some researchers instead use multidimensional quality metrics. This requires very professional annotators who, instead of assigning scores, highlight errors in the translation and assign error severity and categories. The final score is computed automatically based on these bands. This is much more objective and robust, but also costs much more. So we have fast, cheap, but unreliable direct assessment, and slow, expensive, but reliable MQM. For the latest WMT general share task, we created a new protocol called error span annotation, which bridges components from both of these. Here's how it works. First, annotators highlight errors in a translation. Each error is marked as either minor or major, similar to MQM, but without the error categories. Then they provide an overall score, similar to direct assessment. So how does ESA perform? We tested this on an evaluation of 13 English to German state-of-the-art translation systems. The goal is that ESA is as good as MQM but much cheaper. Let's focus on the cost first. This can be measured in how long it takes for one annotator to annotate a single error. For MQM, that's 99 seconds per annotated segment. For ESA, that's only 71 seconds per segment, so almost 1/3 cheaper. In addition, we don't need to pay for super professional annotators because we don't ask them to produce the error taxonomy anymore. Great, so it's cheaper, but does it produce high-quality annotations? Answering that is a bit more tricky. One way to look at it is to see if two independent annotators in the same protocol produce the same annotations. This is known as inter-annotator agreement, and we measure it with Spearman correlation. For MQM, this is 0.335, and for ESA, 0.376, so comparable in terms of stability. Okay, so we know that it's more consistent and reliable, but why? On the surface, it seems that we are doing exactly what direct assessment is doing, asking annotators for final translation scores. However, before they do that, they have to go through annotating the individual errors, which primes them to provide more accurate final assessment. Now, MQM and direct assessment aren't bad protocols, they both have their uses, for example, in diagnosing the empty output. The General WMT Translation Share Task adopted ESA in 2024 as the Human Evaluation Protocol because of its combination of quality and scalability. Finally, let's take a look at how the annotation interface looks in practice. First, we read the translation, then we mark all the errors, and finally we assign a final score. The translations are also ordered within a document, so the annotator can also verify document-level consistency. This protocol can also be used for annotating different modalities, such as video-based translation. That was error span annotation in a nutshell. If you want to learn more, check out the full paper. Now let's dive deeper into a refined version of this protocol. Imagine that you are an annotator, and your task is to find all the errors in this translation. It might take you a minute or two to read through the whole text, but then you find all the errors, you decide the severity, and determine the final translation score. However, this might take you a very long time if your task is to do this for, say, 1,000 paragraphs. Let's consider a different setup, where you have an unreliable but beautiful colleague that pre-highlights places in the translation that have some potential errors. Now your job is much easier. Instead of having to scrutinize the whole text, you can now focus on these pre-highlighted spots. Then you decide if there's really an error, what the severity is, and the final translation score. It comes as no surprise that a hypothetical colleague doing the pre-annotations is some automated system. And for this we created the ESA AI protocol, a refined version of ESA. An important part is that the quality estimation system doing the pre-highlighting is recall focused. That means that it's more likely to report an error where there is none than vice versa. In ESA AI, the translation first goes to a quality estimation model that supports board-level MQM or ESA-style annotations, such as Gemba or XCommat. Only then does go to the annotator, who makes further edits, and at the end gives a final translation score. It's quite important that the final score comes from a human, not the quality estimation, to avoid bias. We tested this on a follow-up user study for MT system evaluation. The goal was that the ESA is as good as standard ESA, but cheaper. Let's focus on the cost first. This can be measured in how long it takes one annotator to annotate a single translation. For ESA, this time is 58 seconds, and for ESA AI, it's 52 seconds. That does not look so good. Saving 6 seconds on average is maybe not even worth the effort. However, on average, we get 1.6 errors per translation from the ESA AI protocol, and only 0.5 from ESA. This is important because the more errors the annotators find, the higher the quality of the annotation protocol. Now, when we normalize the annotation time per annotated error, ESA takes 71 seconds compared to only 31 seconds for ESA AI. Cool, but apart from the number of detected errors, how do we know that the annotation protocol is also of high quality? Again, we turn to inter-annotator agreement, which measures how similar two independent annotators annotate the same translation. And again, we measure it by Spearman correlation based on the final translation score. For ESA, that's 0.376, and while for ESA, that's 0.533. This is one of the reasons why we ask only the human annotator and not the quality estimation model to provide the final score, to mitigate biases. Read the full paper if you are interested in other ways to measure annotation protocol quality. By the way, there's one more thing that we noticed. In 24% of cases, the quality estimation model highlighted no error in the translation. And when that happened, the majority of annotators agreed and confirmed that there are no errors. This is because the quality estimation model is recall focused. Now, when we know beforehand if a translation will lead to 0 human annotated errors, why not simply skip the humans? If we do that, then the resulting evaluation will have only one incorrect system ordering. And this is actually a pretty sweet deal, because we just saved almost a quarter of our budget at a very minor loss in evaluation accuracy. Selecting examples for human evaluation is an interesting problem in itself, which we cover in upcoming follow-up work. That was Aerospan Annotation with AI. Read the whole paper if you're interested in additional insights, such as, do annotators learn how to cooperate with AI, or do they lose trust in the AI if it misses an important error? Thanks for watching.